All right, here we go for another example of a one proportion z-test. In this case, we're talking about a quality control manager of an ice cream manufacturer that claims that 85% of his 1 million customers are very satisfied with the distribution of chunks in the ice cream. I'm guessing that's like chunks of cookies, maybe? I don't know. To test this claim, the local newspaper decided to survey 200 customers using the SRS. Among those that they sampled, 164 were very satisfied. So based on this finding, can we reject the quality control manager's hypothesis that 85% of the customers are very satisfied? And we're going to use an alpha of 0.05. So I went ahead and defined the parameter here, P, and put that's the true proportion of customers that are very satisfied with the distribution of chunks. And I went ahead and calculated P hat for us. We'll need that later on. Notice that it is about 82% that got that out of the sample that were satisfied. So not a very big difference from 85%, but it is a difference. All right. So far I've already kind of completed the P in Phantom. That's that one. Now we're going to state the hypotheses. So remember there are two, the null and the alternative. For the null, it's always going to be P equals in whatever they claim. In this case, they claim that 85% of the customers are very satisfied. So we've got to decide, what are we testing here? Now, we did get a P hat that was lower than 82%, or sorry, than 85%. So we could test maybe that the true proportion is lower. But if I look at the wording of this, that's not really what they wanted us to figure out. They said, based on these findings, can we reject the quality control manager's hypothesis that 85% of the customers are satisfied? That doesn't necessarily say, can we say that the satisfied customers is less than 85? They just say, is it wrong? So since they're not telling us, is it less than 85% or greater than 85%, we are going to choose not equal. So pay attention to the wording to help you choose the correct alternative hypothesis. Our assumptions. Okay, we are taking a random sample, so 200 luckily is less than 10% of his 1 million customers, right? So we're good with independence. Okay, it did say that they used a simple random sample, so that helps that there's no bias here. So an SRS was used. So now we're going to look into normality. So let's see if it's normal. So to test that, we're going to find the expected number of successes and failures based off of their claim. So we would expect N times P, so that's going to be 200 times 0.85. That's, remember, we only use that P hat like once in this entire thing. We use P most of the time. So 0.85 times 200 gives me 170. So 170 customers to be very satisfied. And 200 times 0.15 N times Q, that would be 30. We'll just say not to be. Since both are at least 10 a normal approximation is appropriate. All right, conditions check. Now let's name our interval since the conditions have met. I will construct a one proportion z test. And I like to always put here a reminder of my alpha that they told us in the problem. Now it's time for our test statistic, which I can rewrite that right quick for you. That's going to be okay. So here's the only time we really use that 0.82 that we calculated for p hat. $200 was our n. Good. Now, I could type all of that in, but if you guys remember, we have our calculator function stat test, and that gives me my z. So I'm actually going to hold off, and well, actually, I'm going to go ahead and put that in my calculator. So I'm going to go to stat, over to test, and number 5 is where I go. I'm just going to write this for you guys and I'll erase it. Remember that our P0 is the claimed P, so 0.85. Our X was 164 out of 200, so 164. That was the number of successes out of the 200 that we sampled. And then choose not equal to P0 because that was our alternative hypothesis, and we're going to hit calculate, and our z is negative 1.188. That's what it tells us, like that first little z calculates it for us, so we don't have to worry about messing that up. For the O, obtain the p-value. So that means I need to start with a quick curve. Standard normal curve. It's very easy to draw. Very easy to label my z. Now, we've got to be careful here. This is a not equal to problem. So I am testing that it could be possibly higher than 0.85 or possibly lower than 0.85. So I'm going to go to negative 1.1 here, but also positive 1.1 here. So I'm looking for the probability that the difference or the distance away from our 0.85 claim is at least 1.188 standard deviations. So I'm finding that probability right there, that two-sided probability. Let's label this Z. Okay. So I'm just looking for the probability that Z is, I can kind of like write it in two ways. Z is less than negative 1.188 plus the probability that Z is greater than positive 1.88. So this is what we have to write for our two-sided test. And we already know the answer to that. It's given to us in the stat test 5. You'll see it in the third line down, 0.235. So about 23.5% is our p-value. And now we're to the final statement here. Since our p-value of 0.235, that's obviously greater than our alpha of 0.05. Yeah, that's pretty big shaded area there. So we will fail to reject the null hypothesis, okay? Because we're not surprised. That 82% that we got happened by chance, or at least the distance of that happened by chance 23% of the time. So it's not very significant is what we would say here. Not significant. So we would say there is not sufficient evidence that the claim of 85% satisfaction is not true. And we did it. All right, thanks guys. Let me know if you have questions.